In this video, we'll be looking at continuity. A function f is continuous on the closed interval from a to b if it is continuous on the open interval from a to b and the limit of f of x as x approaches a from the positive direction is equal to f of a, and the limit of f of x as x approaches b from the negative direction is f of b. Let's look at this definition a little more closely. If this curve is our function f of x, what this is saying is that f of x is continuous on the open interval, so from a to b we have no holes, gaps, or jumps, and the limit of f of x as x approaches a from the positive direction. So we're coming in from the positive direction on the function, so we're coming in this way. The limit is f of a, that's there, and the limit as x approaches b from the negative direction, so coming in this way, is f of b. So that y value is f of b. So as an example, we're asked to discuss the continuity of f of x equals the square root of 1 minus x squared. Okay, so here we have a graph of that function. So our first thing to look at is, first of all, is it continuous on the open interval? And we can see that we have no holes or jumps or gaps. Then we want to see if the limit as x approaches -1 from the positive direction if that's equal to f of -1. Now the limit as we're approaching -1 from the positive direction, we can see that that y value is 0. And f of -1, if we put -1 in, we get square root of 1 minus -1 squared. So that's square root of 1 minus 1, which is also 0. So that is true. We also need to check the other endpoint. So we need to check and see if the limit as x approaches +1 from the negative direction is equal to f of +1. So as we come in closer and closer to this endpoint on the function, we can see that that limit, or that y value, is 0. So 0, and then we need to see if f of 1 is also 0. So square root of 1 minus 1 squared. This is 0, so we do have that. So our problem asked us to discuss the continuity, and we would say then that f is continuous on the closed interval from -1 to 1. In this problem, we're asked to describe the intervals on which each function is continuous, and our first one is f of x equal tangent x. Now we know that the tangent function is undefined at pi over 2, and negative pi over 2. So let me list these. And the next one would be 3 pi over 2. And then 5 pi over 2, etc. So we need to show this algebraically. We can write this as pi over 2 times an odd number. So 3 times pi over 2, 5 times pi over 2. And we can guarantee an odd number algebraically by stating 2n plus 1, because 2n is an even number, and when you add 1 to an even number, you get an odd number. So let's simplify this a little bit. Pi over 2 times 2n is pi times n, and then pi over 2 times 1 is pi over 2. So we have tangent of x is undefined at these values for n an element of the set of integers. Therefore, f of x is continuous on negative 3 pi over 2 to negative pi over 2, negative pi over 2 to pi over 2, pi over 2 to 3 pi over 2, and so on. And I think this would be the best way to show this continuity instead of using this one. This is undefined. And then let's look at polynomials. Notice this one is continuous on the entire set of real numbers, and we would say then that it's everywhere continuous. And note, all polynomials are everywhere continuous.